What if I told you engineers built a bridge whose road hangs higher above the river than the top of the Empire State Building? It sits so high that planes could fly under it on a clear day. The big main cables hold tens of thousands of tons. Yet the whole bridge was made so a strong earthquake that would knock down most crossings leaves this one standing and open for traffic. Before the trip took Guizhou's detours called of in Mogul areas for Volgal area. In Guizhou, earthquakes and deep gorges blocked every road. Leaders vowed to build a link, no matter the cost. But every normal plan failed on the drawing board. Now, innovation rises against the odds. Strong wind numbers, shaky rock, and the sure chance of big earthquakes stopped them all. After years of ideas that did not work, one team's plan for a suspension bridge with strong main cables finally won approval. Work started on January 18, 2022. The finished bridge had to stay open and safe even after a design-level quake that would flatten ordinary structures. Machines could not get to the steep cliff faces. Workers climbed down and drilled deep holes by hand into the solid rock below. They fixed strong anchors in that hard bedrock. A temporary cable system stretched across the gorge, carrying tools and gear. Crews blasted careful paths into the cliffs, so people and machines could move around. Two teams worked at the same time, one from each side. Workers dug big foundation pits at the base of each tower. They poured huge amounts of concrete into those pits without stopping. Thick steel bars filled every pore to make the bases extra strong. Special forms climbed the towers by themselves. They rose several meters each day. Lasers checked the height and straightness all the time. If a tower leaned even 1 degree, the crew had to tear the work down and start over. The job never paused for cold winter weather. Both towers reached their full height in just a few months. Each one was built to hold far more cable pull than normal bridges need. A massive M7.8 earthquake tests these towers. Their base isolation system allows safe, controlled shifting. A helicopter flies the first thin guide wire. Workers use it to pull the main cables into place. Each cable holds thousands of steel wires. Workers pulled those cables to the exact right tightness, staying within 1% of the perfect number. As the cables took their load, crews hung ready-made deck pieces one after another. They tightened the cables step by step so each new piece lined up straight with the last. Special shock absorbers fixed a shaking problem that showed up during the work. The decks grow from both towers, converging in the middle. With one gap left, cables are adjusted to fix the tilt. Now, the final piece is lowered, measured in millimeters. A testament to precision engineering. These parts are made strong enough for the worst earthquake this region might ever face. The deck can move on its own without dragging the towers with it. The bases of the towers reach deep into solid rock. Workers used angled piles and treated the soil so it will not turn soft and watery during shaking. The bridge has extra ways for the weight to travel. If one steel piece bends or even breaks, other paths still hold everything up. The crossings of sensors, triangles of the cables, towers, and deck. They send live numbers to give a watch. The builders had to bridge to Britain again for emergency traffic within just a few hours after a design-level quake. That rule is much tougher than the normal codes for ordinary bridges. Workers paved the road surface without stopping for a full day and night. They laid a strong layer that could handle heavy traffic. Special gaps in the deck were cut wide for the road to band shrink with hot and cold days. Those same gaps also let the deck slide farther during a big earthquake. After a final check that filled thousands of pages, the bridge was ready. It opened on September 28, 2025. The first official group of vehicles crossed in just 2 minutes, a tiny fraction of the old 2-hour mountain trip. Travel times that once took hours now take only minutes. Trucks carrying goods and emergency vehicles reach places far faster than before. Counts from the first day and the first year showed how completely the bridge changed daily life.
After all these years, it's finally here.
The lights, they're coming on. It's happening.
No more waiting. We're connected.
Look at the cars crossing. Our world is changing. Hooray, the future is here.
This bridge earned Guinness World Records titles for being the highest in the world and for its long span over mountain land. Rise 165.7 meters of the valley floor with a main span of 1,244 meters. It stands as a symbol of human achievement. They said it was impossible, too high, too expensive, too dangerous in earthquake country. Then they built it anyway. That's what humans do at their best. Hundreds of sensors monitor the bridge every movement. They send live data to the control room. The goal, reopen for emergency traffic within hours after a quake. Verification is in progress. This engineering marvel pushes the boundaries of what's possible. The scale is truly breathtaking. If you want more impossible engineering stories like this, hit subscribe and drop a comment telling me which mega project I should cover next.